All right, so the next thing we're going to look at is independent events. So we define two things to be independent if the occurrence of those two events have no influence on the other, if they are not related. So an example I have off to the right here, rolling a die and tossing a coin. You can see here some examples. Tossing a coin 3 times, draw a card and then replace it, spinning a spinner multiple times, selecting a random student. All of those would be examples of independent events, because if I select one student from this class, it then doesn't influence the other selected students. So with this, if events are independent, we can find the probability of both events happening by multiplying the probabilities. So this symbol right here means and, the probability of event 1 and event 2, or both events happening. And an example of that, before we start looking at these in the notes, rolling a die and tossing a coin, this one I have up on the right-hand side. If I wanted to find the probability of rolling a 2 on just a standard normal die and tossing a coin and flipping heads, I could write this as the probability of getting a 2 and landing on heads. This theorem says that I can multiply the probability of 2 times the probability of a head. Because those two events don't have any influence, if I roll the die, that doesn't affect the coin being tossed. Well, the probability of a 2 would be 1 out of 6. On a standard die, there's 1, 2 out of 6 total sides, times the probability of flipping a coin and getting a head is 1 out of 2. And so I'm able to multiply those and get the probability of a 2 and a head would be 1 out of 12. All right, so let's look at this other example. There's a 25% chance of snow tonight and a 50% chance of snow tomorrow. What is the probability of snow both tonight and tomorrow? So I'm looking for the probability of snow tonight and the probability of snow tomorrow. Essentially, that's what I'm asking when it says for both tonight and tomorrow. Now, when I have percentages, first thing I want to do is translate that into decimals. So remember our DP, Dr. Pepper. Decimal to percent, we're going to move the decimal to the right. Percent to decimal, we're going to move it to the left. So that's going to be 0.50, and that's going to be 0.25. Now, what our theorem says is if I want to find the probability of something and something else, I can just multiply those two probabilities. 0.25, because that's the probability tonight, times 0.5, because that's the probability tomorrow, and I get 0.125. And you can just leave it as a decimal. But if it asked me for a percent, I'd move that decimal place 2 spots back to the right. So I could also write this as 12.5% or 0.125. All right, so now it says, what is the probability that it will not snow either day? So either tonight or tomorrow. So the probability of no snow tonight and the probability of no snow tomorrow. Now, if there's a 25% chance of snow tonight, the chance of no snow tonight would be 1 minus that, or 0.75. Times the probability of no snow tomorrow. Well, if the chance of snow tomorrow is 50%, then the chance of no snow would be 1 minus that. 1 minus 0.5 or 0.5. And then when I multiply those two, I'm going to get 0.375 or 37.5%. Honestly, I would just leave these in decimals, but either one is correct. I'll accept either. So you can do the decimal version or the percent version. Now be careful, if you are going to do the percent version, you better put the percent sign with it, because 12.5 is not the same as 12.5%. So make sure you do have that percent sign if you go that route, which is a reason why I would just leave it in the decimals. Convert these all to decimals and then just leave it as decimals. What is the probability that it will snow exactly one time? So what I'm looking for is the probability of snow tonight. And then if it snows tonight, because I'm looking for exactly one, that means no snow tomorrow, or probability of no snow tonight and yes, snow tomorrow. So either of those could work. Exactly one day would mean that if it snows tonight, it can't snow tomorrow. And if it doesn't snow tonight, it can snow tomorrow. Okay, so both of those would be exactly one time. Now I need to find each of these individual probabilities. So the probability of snow tonight is this, 0.25 chance of snow tonight. Times, so that's that part. No snow tomorrow would mean 0.5 says it will snow, so no snow would be another 0.5. All right, that's that one. So I've got, for that part, 0.125. Okay, now that's just that part. That's only one scenario. The other scenario would be no snow tonight, yes snow tomorrow. So let's now find those numbers. All right, probability of no snow tonight. So 0.25 chance of snow tonight. So then no snow would be 0.75 times the probability of snow tomorrow. Well, there's a 50% chance of snow tomorrow. So I'm going to multiply those two. And I get 0.375. Now, because I'm looking that either one of those could happen, this scenario or this scenario, I'm going to add those two numbers together. And I'm running out of room. So probability, I'm just going to say overall. But make whatever notes you need to. Is going to be this, which is this, plus this. So I'm adding those two numbers together. 0.125 plus 0.375. And I get 0.50. So the probability that it snows exactly one day would be 0.5. Probability that it will snow at least one. So it could snow one, it could snow both days. I'm just looking for the probability of snow today. Nope, it was tonight, sorry. Tonight or tomorrow. One or the other, both great, fine. So the probability of snow tonight is 0.25. Probability of snow tonight. And the probability of snow tomorrow, 0.5. So the probability that it will snow at least once, 0.75. Not bad. And then this is just a thinking question. In real life, do you think that these two events are independent? No. Snow patterns are not independent. Typically, snow on one day does influence snow on the next day because of weather patterns and cold fronts and whatever else Chris Justice says when he explains if we're going to get out of school or not. Now, we assume that they were independent here because it just makes the math a lot easier. But out in the meteorology world, it's not that cut and dry.